Be sure you get the date. All right, how do we use the distributive property within problems? Not just any problems, but it's going to be word problems. You already have them written down on your guided notes. First word problem. I want you to take some time, read it, and maybe underline important stuff. So after looking at the question, type of battery. How many of each type of battery are used? So I'm going to let X equal the number. Maybe I shouldn't have underlined type, I just realized. Maybe I just should have underlined battery. How many batteries? So number of batteries will be my... So I'm going to let X equal the number of 6 volt. I'm just going to pick 6 volt. We could have easily picked 12 volt. But I'm going to make X just be one of the types. So maybe I could have kept that type of battery underlined there. How many of each type of battery? If X equals the number of 6 volt batteries, then like what was just discussed in class, if we know the total is 10, then, well, if we took this away from 10, that's the amount of the 12 volt batteries that we have. All right, 84 volts. That's how many total voltage you've got. Because the combo is 10, if I have 10 and take away the number of 6 volt batteries, then that's going to be the number of 12 volt batteries. So to relate it, I'm going to put it into words as much as possible. 6 volts times the number of 6 volt batteries plus the 12 times the number of 12 volt batteries. That's going to equal the total voltage. Meaning, anytime I say, okay, let's write it, that means let's put in some variables. So 6, what did we call the number of 6 volt batteries? That was our X, because that's what we defined. Then we're adding 12 times the number of 12 volt batteries, which, wait a second, what did we call that? Oh, that was 10 minus the 6 volt. So in parentheses, I'm going to put 10 minus the 6 volt batteries. The number of, that's going to equal the total voltage. We're looking at 84. Okay, so when we start to solve, let's clean it up. So 6 times X just becomes a 6X. And then we're going to do, most of us have done this sort of rainbow looking thing. So 12 times 10 minus 12 times X, that's going to equal 84. So we combine the like terms. We got negative 6X. I still have the 120. Equals 84. Take away 120. So, because I'm running out of room, I'm going to write it off to the side. Divide by negative 6 on both sides. It looks like X equals 6. But then we've got to go back to the making sense point of the story. Like X represented what? The bad thing is I can't see it on my slide, but you can see it on your paper. What did we define X as? So we start writing it out. We have 6 volt batteries, and then because the 12 volt batteries had to be 10 minus whatever X was, there's 4 12 volt batteries. So in this next example, we've got the IRS. You buy a copier for $10,000 and they spit that within their own formula. They put it in their own formula, and this N that you see in this formula is meaning years. After how many years will the copier be valued at 6,500? When we define a variable, we go to the question. It says how many years? Well, what's nice is within the problem, they actually say, they give us a variable and they say after N years. So let's define the variable N to equal number of years. when will the IRS formula equal that value, 6,500? We take the IRS formula equal to 6,500, and we're going to use the distributive property, because like Lauren read earlier, we're going to use the distributive property within this problem. So we're now ready for the solving step. We're going to distribute. Let's put 10,000 over 1 and cross reduce. So after cross reducing, we get 500N. And then we have to go back to the context. So go back to what your variable was defined. All right, so let's take away the words and let's just do a problem. No words to this. Let's do a problem. Okay. So just to stress, it's like a -1 in front of that parentheses that we're going to distribute first. So n, and then -1 times 3n becomes -3n. And then -1 times 4 is -4. So get your like terms together. So at the next example, at this step, another big mistake is sometimes we divide by the wrong number. Ensure that you divided by the number with the variable. So the very last step is dividing by the number with the variable. I can either write my answer that way or that way. It's called a symmetric property.